This is something you should know, yes. All right, for finding volumes, we have two different techniques. We have the discs washers method, and we have the shells method. What's the basic formula for the discs method? You have the integral of, okay, that would actually be washers, that's fine. Big squared minus small squared.
Yeah. Are you looking for the pi r squared?
And then you have a pi, that's correct. And then you would either have a dx or a dy, depending on which way you're doing it, right? I'm just going to put a dx there. Okay, so that would actually be the washers method. The washers method would, you would have pi times the integral from a to b of big squared minus small squared, and that's basically pi r squared. That's correct. What if it's just a solid disk? What's going to happen? It's just a big square. So for the disk, you would just have pi, the integral a to b of, generally it's your function squared dx. What about the shells method? What's the formula for shells look like? 2 pi, the integral from a to b. Okay, it's usually x times the function. But what's x really stand for? X is the radius. It's really the distance from the little rectangle you built to the line where you're spinning. And f of x is the function height. It's the height. And again, we might have dx, we might have dy. One or the other. When you're using the discs and or washers method, how do you know when to use dx and how do you know when to use dy? All right. So, for discs and washers, the rectangle you build must be perpendicular to the line of revolution. So that right there determines if you're using dx or dy. What really determines dx or dy is your line of revolution. So, for example, if this is my shape right here, if this is my area, and I tell you, I want you to spin around this line, then if you're using discs and washers, you should right away be able to tell me, do I need to use dx or do I need to use dy? Absolutely, I need to use dy. How come? Because I'm going around a vertical line, so when I build my rectangles, I have to build them horizontally. Now, as I've drawn that picture, this would be a very, very, very difficult one to do by discs and washers. How come? There's a bunch of different pieces, aren't there? So sometimes we go from that axis to that line. Sometimes we go from that curve to that curve. Sometimes it looks like we go from there to there, and then we would need another piece that goes there to there. You would need at least 4 different integrals. That would be a very, very difficult one to do by the disc washers method. But this one you would definitely use dy. And the way you can tell is by looking at your line of revolution. If your line of revolution is vertical, then you have to build horizontally, and anytime you build horizontally, you use dy. How about for the shells method? How do you tell if you're going to use dx or if you're going to use dy? The rectangle you build must be parallel to the line of revolution. So if I have the same basic shape, I'm sure I can't draw that exact same picture again. It'll look something like this. And again, I told you to spin around some line over here. If I'm going to use the method of shells, would this one be a dx problem or would this one be a dy problem? This one would be a dx problem because your rectangle has to be parallel to your line of revolution. So your rectangle is going to be built up and down. That's always dx. For this one, I think if I was using shells, I think I would need two integrals. Because sometimes we go from this curve to that line. Sometimes we go from this curve to that other line. So I think this one would need at least two integrals to do it by shells. Questions about that? Okay, I just wanted to do one or two more shells problems today. We did a few of them the other day. And then I got some exciting problems for you to try. Excuse me?
Disc is spelled with a C. I always read it with a K. I don't know why.
I wrote it with a C.
Yeah.
I don't know either. It's with a C here.
It's K on your lab, so.
It's K on the lab? What is it in the book? It's probably K.
Probably C.
Probably C. Well, we'll find out here.
It's the same sentence.
K in the book, so it should be a K. I don't know why I used to see that. I can fix it. Okay. It's all okay now. All right, so we need a couple functions. Anybody got a couple functions?
What's x squared minus 2?
X squared minus 2. F of x equals x squared minus 2.
Y equals 7.
Y equals 7. All right, so this would look like this. X squared minus 2, that's a parabola with the vertex at 0, 2. 0, negative 2. And y equals 7 is up here somewhere, like so. So where do those cross?
At some number, comma 7.
At some number, 7. Very good. Can you be a little more specific? How about 3? Because 3 squared is 9. 9 minus 2 is?
I actually made it 9.
7. You actually made it. You picked a good number.
Wow.
All right. 3, 7. Negative 3, 7.
I was thinking it was like somewhere in the 2s.
Somewhere in the 2s. All right. Let's say, well, what line do we want to spin around?
Y equals 7.
We want to spin around y equals 7. All right. So we're going to spin that shape around y equals 7. I'm using the shells method. So if I'm going to spin around y equals 7, how do I build my little strip? Across or up and down? Across. It's got to be parallel. Using the shells method as parallel. And I think we've done this trick many times. I think I'm going to find half the volume. I'm only going to go from there to there and then double it. Why would I only do half and double it? Because it's easier, especially if I have to figure out the whole problem, get the number at the end, because this will allow me to stop at 0, which is always a nice thing. All right, so our answer is going to be volume is 2 pi. The integral. What are my bounds of integration? What's my interval that I'm working on? 0 to 3, no. 0 to 7, closer. Negative 2 to 7. Why negative 2 to 7? Because we're using the y values. This got to go from the lowest y value to the biggest y value. Negative 2 to 7. Okay. Radius. What's my radius? 7. No. 3. No. No. Can't be x. It's definitely got to have a y. It can't be x because we're doing. All All right, so the radius is the distance from where you built your little rectangle to the line that you're spinning around. So this is our radius. That's our distance right there. It's always the distance from your rectangle to your line of revolution.
Root y plus 2.
Not root y plus 2.
7 minus root y plus
Getting closer. 7 minus something. Not x. Seven minus y. Okay? Because how long is that distance right there? 7. How far is this distance right here? Y. So how far is that distance right there? 7 minus y. So your radius is always going to be x or y or a number minus y or y minus a number or x minus a number.
Would that work? Because don't you have to go all the way down to -2?
Uh-huh.
So we have to do a second?
So notice that if my strip is down here, say my strip's down here at y equals -1, then 7 minus y would be 7 minus -1, which would be 8, and that would be the correct distance, wouldn't it? Okay, so it doesn't matter that my y's go down into the negatives. The 7 minus y will still work. It still gives a distance from there to there.
Why would it be 9?
Excuse me?
Why would it be 9?
Well, when I get all the way down to the bottom, I would have 7 minus -2. So that length would be 9.
Yes, why would it be 9 minus 1? No, the rectangle anyway.
Right. Why isn't it 9 minus y? Because y is based off the x-axis. So we need this distance to also be based off the x-axis. Okay? All right. And then we need the length of this strip right here. So how long is that strip right there? Close.
7 minus root y plus 6.
No?
Y plus 2 all right?
So we have y equals x squared minus 2.
You add 2 and then root the whole thing.
So you add 2, so y plus 2 equals x squared. So that distance is square root of y plus 2 dy.
The reason why we doubled it was because you wanted to find the left side as well.
Oh, actually, I haven't doubled it yet. Because remember, our Shell's formula has 2 pi right from the beginning. So you're right, that's not the correct answer. I need to double the whole thing. There's the right answer. Because I only did half of it. Questions on that? All right, let's take that exact same shape. So this is still y equals x squared minus 2. This is still y equals 7. But now let's spin it around a vertical line.
Why not 0?
Around the wire.
X equals
Okay, we'll do it around the y-axis.
Then you only have to do half of it and you don't have to double it.
I only have to do half of it and I don't have to double it. Excellent. How come I only have to do half of it and I don't have to double it?
It's symmetrical, so.
Because when this side spins around and comes over here, it's going to completely finish that one. Yes?
What happens if we were to say y equals -1 and spin around that axis?
All right. Y equals -1 would be a distinct problem because y equals -1 would be within the middle of the shape. We will never do that in this class. Okay, we could do y equals -3 over here, but we would never do y equals -1. Our axis of revolution will never be in the middle of our graph. All right, so let's start. Let's do the origin first. Or not the origin, let's do the y-axis. And then we'll do a different line. All right, so if I'm using shells, how do I build my little strip? Vertically. So my little strip has to look like that. One of us is getting text messages. Hope it's not me. Didn't sound like me. All right, so our volume would be 2 pi integral dx or dy? Dx, because we built up and down. What are the x values that we're going to use? 0 to 3. What is my radius? Radius always has just x or y, or x plus a number, or a number minus x. Radius is just x, because the radius is the distance from my line of revolution to where I built my strip. In this case, that distance is just x. If you're spinning around the axis, the radius will always be x or y, depending on which way you build your strip. Now, I think you were giving me the height. So what's the height? How tall is that strip? No, everything's got to be x's this time. We're doing dx. Top minus bottom. So it's 7 minus x squared minus 2. 7 minus x squared minus 2. Questions on that? Yes?
What is your personal formula for choosing washers or discs? I mean, shells or discs and washers?
My personal, I look to only have to have one integral, which I think is easier. For this case, I don't think it matters. I think we could do shells or discs. I don't think the number of integrals would matter. And then I try to avoid things like this. Why would I try to avoid that? Because in order to solve it, I'm going to have to use U substitution. So I try to avoid, if I'm going to have to do square roots, I don't want square roots of an entire thing. I just want square root of x or square root of y. So those are the things that I kind of look for. I try to keep it to one integral. That makes it easier in my opinion. And I try to avoid situations where I'm going to have to use U substitution. All right, last problem. Let's take that same shape and spin it around a different vertical line. I think somebody before said x equals 4. X equals 4 would be over here. What changes if I spin around x equals 4? Volume's going to be 2 pi integral. What's my interval? That doesn't change. X still goes from 0 to 3. What's my radius? 4 minus x. There's a change because my radius is now this distance, which is 4 minus x. And then how tall is the strip? 7 minus x squared minus 2 dx. So what's the only thing that changed? The 4 minus x. The radius is the only thing that changed. Oh, I got bad news. That's the wrong answer. One more thing we need to change. Do you remember when we did this one, when we spun around this axis? We said we only needed to do half of it because this side's going to come around and catch that side? For this one, we have to do the whole thing, don't we? So we don't get to go from 0 to 3. Unfortunately, we have to go negative 3 to 3. And when I spin around this line, you can see it's not going to be symmetric anymore. Because, this side, when you spin it around, isn't going to be nearly as big as that side when you spin it around. So you do actually have to go from negative 3 to 3. Questions on that?